Hello, my name is Yarkın Müftüoğlu. I'm computer science student at Bilkent University. This video is recorded for PHYS101-Lab project. Today we will try to establish a connection between kinetic energy and damage volume. To do this, we need to give different objects different kinetic energies. Measure these energies and compare the damage caused by these objects during the collision. Well, how can we do that? Firstly, let's know equipment we need for our experiment. Two objects that are identical in volume and shape, but have different masses. Wire, a bowl, freezer bag, ruler, water, graduated cylinder, and floor. Now we have all necessary equipment. Let's start the experiment. As I said, we need two objects which they have different kinetic energies at the time of collision. To ensure this, we will benefit from potential energy kinetic energy conversion. As you know, if air resistance and fraction are neglected, the mechanical energy of free-falling object is preserved. Therefore, the negative change in the potential energy of this object is equal to positive change in its kinetic energy. In other words, we can say that the initial potential energy of a released object is equal to its kinetic energy when it hits the ground. Then let's determine the potential energies of our objects. This is the formula of the potential energy. Since we already know the constant g, that is the acceleration of gravity, there are two unknowns we need: mass and height. We are measuring of our object masses. The heavy one is 153 grams. The light one is 37 grams. Now let's determine two different heights to release the two objects: 30 centimeters and 15 centimeters. In this way, we have four different potential energies at the time of release. This means we have four different kinetic energies at the time of collisions. Now, to compare, let's measure the damage caused by objects hitting with four different kinetic energies. To do this, we release the objects into the floor and fill the resulting craters with water, and calculate the volumes of the craters with the help of a graduated cylinder. We now have the two pieces of data we are looking for. Now let's draw a graph to determine the relationship between these two concepts. We observe that this graph is almost linear. The slight deviation from linearity could be due to human error, measurement inaccuracies, or air resistance during the experiment. This near linearity indicates a direct relationship between kinetic energy and the damage volume, meaning the greater the kinetic energy of the object at collision, the larger the damage volume it creates.